Welcome everyone to the module MEL Expressions to expand nParticle's functionality. Well, in this module, we'll talk about various expressions and per particle attributes, and we'll see with the help of the MEL expressions, we can widen the scope of nParticle and we can have the broader level of control. So let's get started. Alright, so in this clip, we'll talk about the particle expressions and we'll discuss the RGB per particles, and we'll create some expressions with the help of which we can affect the color of the particles. So let's get started with that one. So let's first of all create a very simple, particle emitter. So we can go inside the nParticle menus and can go for the create emitters, and let's just reposition this. And this time I should prefer to go with the type as a directional because I just want my particles to go in the upward y-axis, and the rate is set to be, alright, 35 is quite good, and the value is y positive. The spread is, let's say, 0.25, and the speed, let's say we go for maybe 15 by 5 random. Alright, now let's also enable the plane so that we can have a ground plane, so where particle can collide actually. Let's also change the particles shading type from points to the sphere, and if we play, you can see we have the particles and the default color of the particle is white. This is just because we have the color which is set to the white. If we can change this thing to, let's say, the cyan color, you can see there's a change in the particle color. So as we have already discussed previously, that we can change the color, we can add multiple colors by generating the more color entry list, and can change the color input from constant to the randomized ID or the particle ID, maybe depending upon the speed or all these kind of attributes. But still we just cannot able to get that much of control, so we actually works on expressions or scripts to get something which is beyond the regular attributes. And I highly recommend to all of you that if you know how to generate the scripts or expressions, then you can able to achieve something bigger and beyond from your regular dynamics. So let's now move to the section in which we can create the expressions. So we're going to work on the MEL, that is the Maya embedded language, the MEL. Alright, so if I open this tab, we have the per particle array attributes. So per particle stands for all these attributes. They include these are the attributes which affects the particle on the individual basis. That means now we're not talking about the entire particle object. Actually, now we're talking about the per particle. That means every individual particle. So to bring the color inside the particles, we can use a simple function, that is, say, or you can say simple attribute, that is the RGB PP, that stands for the per particle. So for that we need to go inside the color and we have to pick this add per particle attribute. Hit the option add attribute. The moment you hit, you'll see you have the RGB PP. Alright, so let's change the particle color. Let's go with this, right click, use this create expressions, and the moment you open this, you'll find you are now inside the expression editor. Alright, so here is the space where you can write your own expressions. So we always type about the name of the object and the attribute. Right now the object name is nParticle shape and the attribute is RGB PP. Pretty straightforward. So let's write it down. It's nParticle P capital nParticle shape 1 dot RGB PP equals to, and let's say we talk about with a very simple expression. Let's say we have, now as we know that RGB is actually a vector value, it contains three values, that is the red, green and blue. So we have to bring them inside the vector. So let's say we want to change the particle color to the red, so we go with 1, 0, 0 and then close this and put the semicolon to terminate this. Hit the option create. Now if you roll back your timeline, now you can see your particle color has just changed to the red. So what if we just want to have some more random color inside the particles? Well, we can do one thing. Let's go back again, and now let's do one thing. Let's give some another expression over here. Let's say we go with the 1, 0, 1, and now let's put it inside the random function. So the job of the random function is to create the randomized values, and these values are between this and this. So let's say if it is A and it's B, so this function which is rand will going to randomize the values between these two. And how it will work, it simply works in a way like every particle which is taking the birth will accept this expressions on per particle basis. Hit the option edit, and we can also put the semicolon. And now if we play the timeline, you can see the particles are changing their color, but you also can see one thing, that particles are simply taking only two color, that is the red and this is the magenta, because here what we have the variations between these two only. So how can we add some more randomness? Well, that can be possible. Let's say if I copy this and put a comma, paste this, and let's bring them inside another random functions. All right, so with that you can create this thing, you can add some more randomness. All right, so that can be possible. Let me just maximize this and make sure that we are not doing any errors, and I think so it's pretty much nice. And now let's change the overall expression, since it's absolutely the same. So now we bring the value of the green RG, red, green and blue, and bring it back to the 0. All right, now hit the option edit and make sure that if there's anything wrong, then it is giving us error over here. So now we need to rectify that. So what exactly is the cause of the error, we need to know. And actually this is the cause. All right, because ran, now a comma, another ran, and there we go. So hit the option edit. Now we don't have any error. Now if we play the timeline, you can see we have much more randomized colors. All right, now what if I just want to change the color every frame? Well, that can also be possible. Let's say we go inside this. Now notice one thing, when we are actually creating the expressions, we are inside the creation mode. Notice one thing, we have particle, runtime, before, after dynamics, and the creation. The creation mode simply means that the execution of your expressions will affect the particle just for once during the time of the birth. If you want to affect these expressions on per frame basis, that means for the entire timeline, then you need to take your expressions inside the runtime, either before or after dynamics. Now here the word dynamics is equivalent to the fields, collisions, goals. So for example, we have turbulence fields, so the execution of the expression is before the effect of the field or after the effect of the field. So right now as such we don't have the dynamics, so let's say we can consider any of them. So let's go inside the runtime before dynamics, paste this and create. And now if I play the timeline, you'll notice very clearly that particles will start changing their color on per frame basis. So take a look at here. All right, pretty nice. So with the help of this, we can now affect the particle colors based upon every single frame. All right, now this is pretty much okay kind of thing. Now we have just started into the the fields of expressions and all. That's pretty much okay, but we are not actually learning only to change the color. Let's do one thing, let's get beyond this. So if in case you want to clear this, you can simply go over here and click the option clear, and don't forget to hit the option edit, otherwise it won't get refreshed. Now inside the creation mode, again we can clear and press the option edit, and now if you play the timeline, you'll notice that the particle will back to its own original color that you have already given here inside the shading attributes, and that is the color. So this is the default color. So now let's do one thing, let's affect the particle color based upon the IDs of the particles. Now you must be wondering that what exactly is the ID? Well, the ID is the unique identification number for every individual particle, and every individual particle has its own unique ID. Let's do one thing, let's go inside the shading section and change the particle render type from sphere to the numeric. Now the moment I change this to the numeric, you can notice particles are showing us with some unique identification number. Some of them is with the value of 32, 33, 34, 35, and every individual particle has its own unique ID. If we just refresh this and notice, we have the attribute name, which is the particle ID. We can change this. Let's say if I type the mass, so with the help of this, now every particle has a value of 1, so that's why all the particles are displaying the attribute and its magnitude, that is the mass. What if we have the position, let's say? So right now we have three values because position is a vector. So we have x, y, z. So this is really very important and very much essential if you want to query, if you want to exactly know what exactly is happening on per frame or per particle basis. It's really very essential to get into the process of this thing. So by checking on the Maya viewport is absolutely a great way to examine what exactly is going on inside your scene. So let's do one thing. Let's get back to the the particle ID. So we can simply write the particle I capital and D, and here we go. Or you can just simply type the ID, not a problem. All right, so here we have the particle ID. Now let's do one thing. What if we want to change the particle color based upon the ID? Or let's say if I give you a condition that if I divide the ID with the value 2, then if the remainder is 0, then particle color will change to the red, and if the remainder is 1, then particle color should change to the green. So let's do one thing. Let's take a pause over here and we'll continue this thing in the next clip.